Okay, here we want to start solving trigonometric equations. And those are just equations, regular equations with trig functions in them. All right, so let's start with a little bit of review of algebra because trig uses the same steps. All right, now when you have an equation in algebra and you're asked to solve, you're trying to get x by itself. All right, you want to isolate the variable. So in this case, using algebra, we would add 1 to both sides, right? And we'd have 2x equals 1. And then, of course, using our algebra steps, we would then divide by 2, and we get one solution here. So the solution is x equals 1/2. If you were to actually substitute 1/2 into the original, you would get out 0, right? That's what it means to solve. Now we're going to do the same thing over here with a trig equation. So we have an equation, there's the equal, and we want to isolate the variable, but the variable this time is sine theta. All right, so that's going to be your first step. Adding 1 to both sides, we get 2 sine theta equals 1. And then, dividing both sides by 2, we isolate the variable here, sine theta equals 1/2. Now, in algebra, you are done, right? One solution. In trig, you're not done, because this, we know, has infinitely many answers. Sine is positive in quadrant 1 and also in quadrant 2. Now, we know we can get the quadrant 1 answer, our reference angle, if we take sine inverse of that ratio, right? And we know sine of 30 degrees is 1/2, or if you do that on a calculator, our reference angle is actually 30 degrees here. All right, and so we know here, this has a Q1 answer, infinitely many Q1 answers. I'll show you what that means in a minute, and infinitely many Q2 answers, okay? So the calculator gave us the Q1 answer, right? It didn't give us the Q2 answer here. So theta that we're after is equal to 30 degrees. Now, if you look at your unit circle, here at 30 degrees, sine is 1/2, right? That's 30 degrees. But if I add 360 degrees to that, I get to the same terminal angle, and the sine is still 1/2. In fact, if I add another 360 degrees, go around again, I get to the same terminal angle, the sine is 1/2. So you get infinitely many answers. All you have to do is add that period, 360 times n, where n is any integer. Now, n could be negative too. You could subtract 360. So you say n is an integer. And so you get infinitely many answers that terminate in Q1. And you could actually test that, plug in your 30 degrees into the original, and see that you do get 0. Now what about this Q2 answer? Over here, I could see sine is equal to 1/2 over here, right? Sine is equal to 1/2 at 150 degrees. So how am I going to get that answer? To do that, we're going to work through the reference angle theorem. So in this case, the angle that I'm after in Q2 is going to be 180 degrees minus the reference angle, right? That's my reference angle theorem. And so we know the reference angle is 30 degrees. So we have 180 degrees minus 30 degrees. The theta that I'm after is 150 degrees, right? And then I can tack on the 360 degrees and get to that same terminal side. All right, and so I can plug that in, 150 degrees into the original. Sine of 150 minus 1 does equal 0. And we're good. So infinitely many answers in Q1, infinitely many answers in Q2. And so that's the difference between algebra and trig. When you solve for the variable, you're not quite done. Okay, now let's do an example. Here we're asked to solve, and we want to find all solutions to 2 sine x plus 1. All right? So the first step is to isolate the trig function, which is sine x in this case. All right, so we'll do that first by subtracting 1 to both sides. We get 2 sine x equals -1. And then dividing by 2, in this case we get sine x isolated, and that's going to be equal to -1/2. All right? So step 1, isolate the trig function. Step 2 is to figure out what quadrants you're in, because there are going to be infinitely many solutions. And we know here sine is negative in quadrant 3. Right? Y values are negative in quadrant 3, and y values are also negative in quadrant 4. All right, so we're going to get solutions in Q3 and Q4. So now we need to figure out the reference angle. To get the reference angle, you can use sine inverse. So x hat for the reference angle will be equal to sine inverse of the absolute value of the ratio that you get. So the absolute value of negative 1/2 is 1/2. And when we do that on a calculator or we've memorized, sine inverse of 1/2 is 30 degrees. All right, that's not the answer. That's the reference angle. Okay? So in Q3, we know the angle that we're after, the theta, which is x in this case, the variable is x. So the angle that we're after, x, is equal to, it's going to be, in Q3, it's going to be 180 degrees plus your reference angle. Right? Q3, if your angle is down here, you have 180 degrees plus your reference. Right? And so in this particular case, we got the reference to be 30 degrees. 180 degrees plus 30 degrees is, what, 210? And so there's all the solutions. Well, all the solutions, if we tack on another 360, would be coterminal. So we can add 360, or any multiple thereof, 360n to that. And there's all the solutions where n is an integer. That's the notation for that. This fancy z means integers. Anyways, if you were to plug in 210 degrees into the original, right, 2 times sine of 210 plus 1, you would get 0. All right? Now, over here in Q4, we're going to get answers over there in Q4. So in Q4, the angle that we're looking at is going to be 360 degrees minus the reference. Right? Because Q4 is over here. If I go all the way around to 360 and then subtract out the reference there, we'll get the angle that we want. All right, so Q4, 360 minus the reference, we got 360 degrees minus that reference of 30, and so that's going to be 330 degrees. And then I'll go ahead and tack on the plus 360 degrees times n, and you get infinitely many solutions like that in Q3 and Q4. And again, you could plug that 330 into the original and see that you do get 0. Now another way to do this, instead of the reference angle, is to look on your unit circle. The unit circle only works for the angles that we know anyway, so I suggest doing it through the reference angle theorem. But you could see here at 210, at 210, sine is negative 1/2, and also over here at 330, sine is negative 1/2, right? And so I can add another 360 degrees to that and get to the same spot, 210. Right? The same terminal side as 210 by adding 360 degrees as many times as I want. All right, so infinitely many solutions. There they are. These are the answers. Okay, now here's another one. 2 cosine theta minus square root of 3 equals 0, and we're asked to solve, find all the solutions. So the first thing we want to do is isolate the cosine here. All right, so we get 2 cosine theta equals square root of 3. Dividing by 2, we get cosine theta equals square root of 3 over 2. Okay? So that's step 1, isolate the trig function. Step 2 is to get your reference angle. So the reference angle here is going to be the cosine inverse square root of 3 over 2. And so theta hat equals, we can do that on a calculator or we've memorized that theta hat here, cosine inverse square root of 3 over 2 is 30 degrees. We're working in degree mode. Okay, next you want to figure out your quadrants. So cosine is positive in what 2 quadrants? Remember, cosine is related to the x value. X values are positive and definitely in Q1, and x values are positive in Q4. Right? So we know cosine is positive in those 2 quadrants. You got to know your quadrants to solve these equations. All right, so in quadrant 1, the reference angle is the angle that we're after. Right? So the theta that we want is going to be just straight up that 30 degrees. And then we'll tack on our 360n. So there's infinitely many answers to this equation in quadrant 1. Now in quadrant 4 again, the angle that we want is going to be 360 degrees minus the reference. And so 360 degrees minus the 30 degrees is 330 degrees again, plus the 360 degrees n. And then so there's the infinitely many answers in 2 quadrants for this particular equation. Okay, so hopefully you're not finding these too terribly difficult. They're really not. They're kind of fun, actually, solving, algebraic. All right, so here's another one. 5 sine theta plus 3 equals 0. Now, you're not always going to have special angles, and so you're not always going to be able to use the unit circle to solve these. So for this one, you'll see we have to use a calculator. So let me show you this. Steps are the same, the algebra steps. We want to isolate the trig function here, so we get 5 sine theta equals negative 3, right? Subtracting 3 on both sides. And then dividing by 5, we have sine theta equals negative 3/5. All right, so that's what we're working with. Now, the next thing we want to do is determine the quadrants. So sine is negative in what two quadrants? Certainly, sine is negative in quadrant 3 because sine is related to the y value. Y values are negative in quadrant 3, and y values are also negative in quadrant 4. All right, so there's going to be 2 quadrants for these things. Now, to get the reference angle, you take, in this case, sine inverse of the absolute value of the ratio. All right, so here we had negative 3/5. The absolute value would be 3/5. Now, on a calculator, that will be guaranteed to be the inverse, or the reference angle. So make sure you're in degree mode. I'm doing this in degree mode, so sine inverse of 3/5. And you always want to round your angles off in this class to 1 decimal place. So in this example, 36.9 degrees. And I use a little squirrely equals, approximately equal to. All right. And so that's the reference angle. That's not the answer, because we need the angle to be in quadrant 3 for this to work out. And we know in quadrant 3, the angle that we're looking for is going to be 180 degrees plus the reference. Right? That's the formula for the reference angle theorem. We have 180 degrees plus the 36.9 degrees. And so the theta that we're after is going to be that. And that comes out to 216.9 degrees. Now, I wanted all the solutions. So I'm going to tack on 360 degrees times n. If it only wanted the solutions within one period, we didn't have to add the 360n. Okay? So infinitely many solutions there. Now in quadrant 4, the angle that we want is going to be 360 degrees minus the reference, right? That's the formula using the reference angle theorem. So 360 minus that reference of 36.9 degrees, right? That comes out to 323.1 degrees. And again, I'm going to tack on the 360 degrees times n, and then I'll make a note over here that n is an integer. All right, so there's my infinitely many solutions, right? Infinitely many in quadrant 3, infinitely many in quadrant 4. Go ahead and plug those numbers into the original to see that you get out 0 as a check. And we had to use a calculator to get those. Okay, one last example here, this time with tangent and using a calculator. All right, let's see how this is going to work. It works the same way. There's a couple ways to do tangent, but I'm just going to do it the same way we did above. All right, so the first thing we're going to do is isolate the variable here. So adding 7 to both sides, we get 3 times tangent theta equals, 12, right? Adding 7. All right, and then dividing by 3, we get tangent theta equals 4. All right, so tangent is positive, definitely, in Q1. Tangent is y over x, so it depends on both the signs of y and x. So y and x are both positive in quadrant 1. And then also in quadrant 3, right? Tangent's y over x, so both y and x are negative, and in quadrant 3, they're both negative, so they cancel and you get positive. All right? There's going to be a Q1 answer, and there's going to be a Q3 answer. All right? You got to know your quadrants to solve these. All right? And then this is not one of the angles that are special, so what we'll do is we'll do tan inverse of 4 on a calculator to get our reference angle off to the side. All right, and so when I do that, I get 75. I got to round up. So that's going to be 76.0 degrees. Okay, so that's our reference angle. Now let's go back in Q1. In Q1, the angle that we're after is always the same as the reference angle. All right, and so in this case, we'll say 76.0 degrees plus my 360n, and that will get me all solutions landing in Q1. Now in Q3, theta is 180 degrees plus the reference angle. So 180 degrees plus the 76.0, that comes out to 256.0 degrees. And again, that's approximately equal to, let me not make that mistake over here, approximately equal to, and there's my infinitely many solutions if I tack on the 360n. Now, we're done. Those are the answers. You can actually plug those into the original and see that you do get the same thing. But there's a way to streamline tangent. Turns out, for sine and cosine, the period is 360. So when you tack on your 360 on both of those, it works out fine. For tangent, the period's actually pi, right? Tangent repeats every 180 degrees. And so you can actually streamline this, and you'll see this in the answer book. These are sometimes streamlined, and they'll say theta, so both of these can be put together. Theta is approximately equal to 76.0 degrees. That's your reference angle there. Plus, instead of 360 degrees, the period is 180 degrees. So you can do 180 degrees in. And that's the same answer, because if you do this on a calculator, 180 plus the 76 actually gets you to the 256. Right? And so when you write it this way, you can actually put them together. But that only works for tangent, right? Because the tangent here has a period of 180 degrees. So if you just did it the way with the sine and cosine always, you'll get full credit. It's just that your answers might look a little different than the book, right? This is the answer you might see in the book. But either way, full credit, okay?